Year 7 NAPLAN, practice number 2. Question 1. The sides of the large hexagon shown below are twice the lengths of the sides in the small hexagon. Only part of the larger hexagon is shown. Which of the labelled points is the last vertex of the larger hexagon? Okay, and let's have a look here. So this larger hexagon is twice as big as this smaller one. So the length here, we've got 1, 2, 3, 4 along the top there, and here it's 1, 2, which makes sense because this bigger one here is 2 times as big. Okay, now we need to figure out where the last vertex is, and the vertex is a corner. So there's a vertex, there's a vertex, there's a vertex, there's a vertex, there's one, and we need to figure out where the other one is going to go. Okay, so let's draw it in. So we've got, it's 1, 2 there, so we're going to have 1, 2, 3, 4 there, and this way it's 1, 2, I'll change to red now, it's 1, 2 there, so let's have 1, 2, 3, 4. Okay, and it's, change colour again, try a different colour, let's make it purple. 1, 2 along the bottom, and we've got 1, 2, 3, 4 there. So I've filled it in. And the last vertex, the missing one, is going to be at C. Okay, so our answer here is C. Okay, question 2. When Joe follows the instructions in a flowchart and subtracts A from 18, he gets the answer 6. What is the value of A? So 6 times 3 gives 18. And then 18 take A equals 6. So we're trying to figure out what number A is going to be. 18 take A gives 6. So if 18 take 3, what's the value of A? Let's let A be 3. 18 take 3, that leaves us with 15. So no, that's not 6, so that's wrong. What about this next one? 18 take 6, that gives us 12. So 12 isn't 6, so no. What about 18 take 12? That gives 6, so yes, this is the one we want because we get the right answer. So what is the value of A? A is 12 here. Okay, let's go to question number 3. Now, the clock shows a worker's start time in the morning and finish time in the afternoon. How many hours are there between the start and finish times? Okay, so find how many hours before midday the worker starts, then find how many hours after midday the worker finishes. So here we've got 9 a.m. That's 9 a.m. And here is 5 p.m. Okay, so from 9 a.m. to midday, 9 a.m. to midday, that's going to be, we've got 1, 2, 3. 1, 2, 3 hours there. And from midday to 5, it's going to be 1, 2, 3, 4, 5. So that's, we had 3 here and 5 here. 5 plus 3 is 8. So 8 hours. So we've got 8 hours as our answer for number 3. Okay, next question. The Nabob family drove 10,000 kilometres during their tour of Queensland. They drove for 250 hours altogether. What was their average speed in kilometres per hour? Now, take note of the number of zeros in each number. Okay, so we need to find the average speed in kilometers per hour. So they did 10,000 kilometers, 10,000, and 250 hours altogether. So what we're going to do is 10,000 divided by 250, and this is the calculator allowed section. So in this section of the test, we're actually allowed to use our calculator. So we can type in straight into our calculator 10,000 divided by 250. So 10,000 divided by 250 gives me 40. So the average speed here was 40 kilometers per hour. Okay, so 10,000 kilometers, the whole drive, and 250 hours, the whole time they drove. So we go 10,000 divided by 250 to give 40 kilometers per hour. Okay. Next one. This map of an island shows two signposts, the arrow and the lightning. Scale on the map, 1 unit represents 500 meters. What is the actual distance between the signposts? So 1 unit, so one of these is 500 meters. I'll do that in red. Red looks better. So that's 500 meters. So let's count them out. There's one, the actual distance between the signposts. 1, 2, 3, 4, 5, 6. Okay, so I count 6 there. So it's going to be 500 times 6, which gives us, and we can type that into our calculator. So 500 times 6 is 3,000 meters. Now, it's a bit tricky, this one. Okay, so I'll do it in green. Let's actually have a look at it. The distance we should be calculating is going to be, should be this, 1, 2, 3, 4, 5, because the sign, they're not doing it from the, I did it from end, I did it from this end here to that end there. What they want, the answer they want is from this bit here to that bit there, okay, which is only 5. 1, 2, 3, 4, 5. So it's 500 times 5, which gives 2,500 meters. Now, we look, that's not in our answers, so it needs to be in kilometers. So 1,000 meters equals 1 kilometer. So 2,500 meters will equal 2.5 kilometers. Okay, so I'll just show you the conversion chart here. We've got millimeters, centimeters, meters, and kilometers, and converting to each. So to go from millimeters to centimeters, we divide by 10. Centimeters to meters, we divide by 100. Meters to kilometers, we divide by 1,000. Kilometers to meters, we times by 1,000. Meters to centimeters, we times by 100. Centimeters to millimeters, we times by 10. Okay. Now, next. 3.04 times 12.5 is closest to. Let's have a look at this one. We're allowed to use our calculator, so we can figure out the exact answer here. What we would type in on our calculator is just this, 3.04 times by 12.5, which gives 38. Okay, and let's figure out each of these. 3 times 12, again, we can use our calculator, which gives 36. 3 times 13, which is 39. 4 times 12, 48. And 4 times 13, which is 52. So the closest answer is this one, 39. It's 38 and 39. There's only one difference. So that's our closest one. Number 7, a number line is shown. Which one of the points A, B, C, or D would represent the square root of 50 on the number line? So hint, use the calculator to find the square root of 50 first. So what we would type in on our calculator, we click the square root button, we type in 50, then we click equals. So square root of 50 is 7.0711. Okay? Now, where is that going to be on this number line? It's not going to be where A is. It's going to be away from A because A is at 5. So it won't be that one. B is at 6. So here's 6. There's 6. There's 7. So B is at 6.5. So no, it won't be at 6.5. That's 6.5. So it won't be there. D is at, I'll do that in a different color. D, so that's 7 there, and this is going to be 8. That's where 8 would be. So D would be at 7.5. So no, it's at 7.07, which is very close to 7. So it's not 7.5, so it's going to be here at C, very close to 7. Okay, so which of these points? It's point C. Giorgio played in a basketball match. He scored both 2-point and 3-point baskets. He scored 21 points altogether, including 3 2-point baskets. How many 3-point baskets did Giorgio score? Alright. So we've got, he scored 2-point and 3-point baskets. He scored 21 points altogether, so 21 in total, including 3 2-point baskets. So out of that, he did 3 2-point baskets. So 3 times 2 is 6. So 6 of those points were 2-point baskets. So 21, take away 6, gives us, we can type that straight into our calculator. 21 take 6 gives 15. So 15 points were 3-point baskets. So how many 3-point baskets? It's going to be 15 divided by 3. 15 divided by 3 is 5. So 5 3-point baskets. Number 9. The triangle and rectangle above have equal areas. What is the value of h? So the area of a rectangle is equal to length times width. So the area of this rectangle is going to be the length, which is 40, times the width, which is 10. So that's 400 square centimeters. So the triangle and rectangle have equal areas. So if this is 400 square centimeters, then this shape here, this triangle, is 400 square centimeters. Let's figure it out. Now, the area of a triangle, I'll do that down here. Area of a triangle is 1 divided by 2. times by the base times by the height. Okay? And we want it to be 400. All right? We want this area to be 400. So we need to figure out what h is. So let's have a few guesses. We've got 4 different options here. It can be 10, 20, 40, or 80. So let's try some different ones. The first one, the area of the triangle is going to be 1 divided by 2 times by the base, which is 20, times by the height, and let's just make it 10 for this first one. So 1 divided by 2 times by 20 times by 10, which gives area of a triangle being 100. So no, we want it to be 400, so that's not that one. Let's try this other one. We've got the next one, area of a triangle equaling 1 divided by 2 times by 20 times by 20. Area of the triangle equals 1 divided by 2 times by 20 times by 20, which is 200. Not what we want. Let's try another one. Area of a triangle equals 1 divided by 2 times by 20 times by 40. Taking this number, 40. Area of a triangle equals 400. So our answer is, that's 400 there, our area, and they match. That 400 is equal with that one. So our answer, what's the value of h? What's the value of this height? It's 40. Number 10. The lengths of 4 lines are given below. Which line is the shortest? Alright, so we need to put everything to the same units. So I'm going to move everything to millimeters. Okay, because 2 of these are in millimeters. This first one's in millimeters, and this last one's in millimeters. So I'm going to change this centimeters and meters to millimeters. So here's how we do that. We've got millimeters, centimeters, meters, and kilometers. And here's the conversions. So millimeters to centimeters, we divide by 10. Centimeters to meters, we divide by 100. Meters to kilometers, we divide by 1,000. Kilometers to meters, we times by 100. 1,000 times by 1,000. Meters to centimeters, we times by 100. Centimeters to millimeters, we times by 10. Okay, so this first one, 47.01 centimeters. I want to put that to millimeters. So here's how I do it. I've got 47.01 centimeters. So there's my centimeters. And I want it to put it to millimeters. So what I'm going to do is I'm going to times it by 10. Times it by 10. And that gives me, because I'm following this arrow. Following this arrow here. And that's going to give me 470.1 millimeters. So this is 470.1 millimeters. Okay, and next, we've got 0.471 meters. So 0.471 meters. So we've got meters now, and I need to put it to millimeters. Alright, so I'm going to do the first step. I'm going to put it to centimeters first. So I'm going to times that by 100. Okay, so when I times this number by 100, the decimal points can jump 1, 2 spots to give me 47.1 centimeters. And now I've got 47.1 centimeters. I need to go to centimeters here. I need to go to millimeters now. So I'm going to times by 10, which gives me 471 millimeters. So 471 millimeters. So which line is the shortest? So we've got 470.5, 470.1, 471, and 471. So the shortest one is going to be this one here, 470.1. Number 11. All the Year 7 students were allocated evenly across 5 classes. There are exactly 24 students in each class. If the students had been allocated evenly across 6 classes, the number of students in each class would be... So all the Year 7 students were allocated evenly across 5 classes. There are exactly 24 students in each class. So 24 times by 5. We've got 24 students in each class and 5 classes. So 24 times 5 gives 120. Okay. If the students had been allocated evenly across 6 classes, the number of students in each class would be, which is going to be 120 divided by 6. 120 divided by 6, which gives 20. Okay, so 20 in each class there. All right. Find 3.1 times 3, take 1.4 divided by 2. So as long as you have a scientific calculator, you can type this straight into your scientific calculator and it'll figure it out for you. But you need to follow BIMDAS. So what I've taught you guys is BIMDAS: brackets, indices, multiplication, division, addition, and subtraction. All right? This is the order. This is the order we do our operations in. Okay? So we look. Here we have a multiplication, all right, and that's before subtraction. So we've got a subtraction here and a division as well. So the way we do things, brackets, indices, there aren't any brackets or indices in this expression here. So what we do next, we do multiplication. Then we do division and then subtraction. All right? So we've got 3.1. So what you're going to do first, you will do 3.1 times 3, which is, this is if you didn't have your calculator. You do 3.1 times 3, which gives you 9.3. Then you would do 1.4 divided by 2, which is 0.7, and then you could go 9.3. Take 0.7 gives 8.6. So our answer here is 8.6. Now, if you had your scientific calculator, you should type this straight in and it'll figure out the correct answer. Anyway, as long as you have a scientific one, it'll give you the right answer. Okay, number 13. What is the angle, the size of angle AOB? We read it, and it's going to be 65. So it's going to be 65. The way we read it, we read the tops, because these angles are less than 90. So the 90 here is this angle there, okay? And because they're less than that, this angle in here, I'll do that in pink. This angle here is less than the 90-degree angle. We use the small number, and that gives us 65. Okay, so what is the size of angle AOB? 65 degrees. So check whether the angle is acute or obtuse. So this angle in here, acute. That's an acute angle because it's less than 90. An obtuse angle is greater than 90. Number 14. Honeycomb is made up of hexagons whose sides are of equal length. The direction north is shown by the arrow. Buzzy Bee walked from A to B. In which direction did he travel? So Buzzy Bee walked from A to B. If this is north, so here we have north in this direction. Then this way we're going to have south. This way is east, and that way is west. All right. Now, if he walks in this direction from A to B, then that's kind of like this. That's going to be north. That's going to be northwest. All right, so it looks like to me he's walking northwest. So we had to imagine here a compass is placed over the top of the diagram. All right, and generally you'll see questions where north goes up like this. North to the top of the page and south is to the bottom. And then you've got west to the left and east to the right. But what's happened here is this compass has been twisted a bit this way. So it became like this compass over here. All right. Number 15. Ellie bought 4 meters of ribbon. The ribbon cost $3.25 per meter. So 4 meters of ribbon, $3.25 per meter is 4 times 3.25, which gives us 4 times 3.25, which is $13. How should Ellie calculate how much change she will receive from $20? So the change she receives from 20, here's how she would figure it out. 20 take 13 is going to give 7. So she bought 4 meters of ribbon. It costs $3.25 per meter. So 4 times 3.25 gives 13. 20 take 13 leaves 7. So she receives $7 change. And what you can do is type these answers straight into your calculator to figure out which one is $7. So 3.25 times 20 plus 4 is, nope, that's wrong. That's 69. So, nope, that's not it. That's wrong. 20 take 3.25. Nope, that's 16.75. So, no, that's wrong. What about this one here? 20 take 4 times by 3.25, which gives 7. $7. That's looking promising. And 20 plus 4 times 3.25, that's $33. So no, that's wrong as well. Our answer is this one, $7.